All right, so here is my designing rich geometry tasks. The cluster I used was solving real-world and mathematical problems involving area, surface area, and volume. And I used Common Core State Standard Math Content 6.G.A and 6.G.A.1, finding the areas of triangles or quadrilaterals and polygons, as well as drawing them on a coordinate plane. So these were my sources I used, and the first task I chose was walking the block. So here was a map of downtown Salt Lake City. You are starting at the corner of 11th Ave and D Street on the star, and then you have to answer the questions. If you were to walk certain areas, describe the shape of your path, draw and describe in words at least 2 different ways you can walk exactly 8 blocks and end up where you started. So Jessica said the path she took on her walk enclosed a polygon that had an area of 6 square blocks. Draw some possible shapes that her walk could have taken. Was her path necessarily rectangular? So this is kind of using, a real life situation, which I liked. The purpose of this was to apply the calculation of distances on a coordinate plane to real life context. Like I had stated, the explicit coordinates are not given in the problem, and the reasoning for finding the side lengths of the rectangles in the plane is present, and this could, prepare your students for the Cartesian coordinate plane later on. They could also, use this system on the map or choose 0, 0 for the starting point and then, walk to where you're going from there. So you have like a common ground starting point, or, to kind of make it easier for your group of students. This task affords the students the opportunity to reason abstractly and quantitatively as they map out routes and then describe words in their location. Students could also use a structure to find shortcuts to part and then, share different solutions and critique each other. I feel like this could also be a good idea for a project for them to create their own map and make up the questions, and pass it to different kids in their class and have them answer it. So these are the solutions. This is where you would walk for each option. So there is that task. Task 2 is polygons in the coordinate plane. So the vertices of 8 polygons are given below. So you need to plot the points in the coordinate plane and connect the points in the order that they are listed. Color the shape the indicated color and identify the type of polygon it is. So you're finding the area, and then the first polygon, here's your coordinates, and the first polygon is gray. The third polygon is green and has these vertices, so on and so forth. The fourth polygon is brown and had these vertices. The fifth polygon is purple and has these vertices. The sixth is pink and had these vertices. The seventh is blue and had these vertices. And the eighth polygon is yellow and had these vertices. So the purpose is for the students to practice plotting the points in the coordinate plane and finding the areas of the polygons. This task assumes that the students already understand how to find areas of polygons by decomposing them into rectangles and triangles. So that standard is right there. So here would be the figures for that. So they're graphing them on the paper. The gray polygon is a hexagon. The orange polygon is a quadrilateral. The green polygon is an octagon. The brown polygon is a triangle. The purple polygon is a triangle, or a square, sorry. The pink polygon is a triangle, and the blue polygon is a rectangle. So the yellow is a pentagon, and there are many ways to find the areas. One way is to break up, each shape into triangles and rectangles. So that shows you, it gave us one way to do that. And then it gives you the list of all the areas and the square units for that. So basically with my task, I kind of critiqued task 2 and made it into my own because there were some problems I found with it, or things, I would want my students to do. So they're graphing each polygon, finding the area, they're finding the perimeter, but I kind of wanted to switch it up, not just color it whatever color. I wanted them to actually think about it. So I said if this answer of the area is divisible by 2, color it blue. If it's divisible by 3, color it red. And there was no answers that were both. So that's why I was able to do one color and one another color. Second polygon, the coordinates. And then the area, the perimeter, if it's divisible by 2, color blue. If it's divisible by 3, color red. So it's kind of getting them thinking of their prior knowledge as well. It's activating, their divisibility rules. And so on and so forth for the third and the fourth polygon. Then you need to answer what type of polygon each of them are. So the purpose of this task is for students to practice plotting points in the coordinate plane and finding the areas of the polygon. This task is guessing that the student's prior knowledge from 4th and 5th grade shows that they should already know how to figure out the area and the perimeter and divisibility rules as well. So these are the solutions, area and perimeter, what you should have colored them, and what type of shape it is. So there is that. It was hard for me to figure out exactly what I wanted to do my activity on. I kind of struggled with it, and I feel like I really liked task 2. There was just some things I wanted to critique. I didn't want them to just color, shape whatever color. I kind of wanted to use a different standard or activate prior knowledge and get them thinking rather than just coloring it whatever color. I also, included the perimeter as well, so they were able to differentiate the difference of area and perimeter. And that is about it. Thank you so much for listening.